All pretty exciting stuff. I want it now. I'm thinking about all the things we could do with it as soon as we have all of those. And that really is part of my role at Comcast. I'm a member of a team at Comcast called DevX. What we're about is enabling our engineers in Comcast to build the sorts of solutions we need to solve the problems that Comcast has today and those problems that we're going to encounter tomorrow. I have the great privilege of leading a team there called DevX Strategy, and we get to think about the sorts of use cases that we are going to be facing and how we put our products together to give our engineers what they need to solve those sorts of problems. And that's what I'll talk about today, what some of our experiences are in putting those things together, how we're imagining how some of those things might work together. But first, let's start with who Comcast is. I imagine many of you know who Comcast is. You might not know all of the things that Comcast does. It starts with our size. We have about 60 million customer relationships. Those are families or businesses. Surely there are more users there. Liga won't let me tell you how many there are, but there are 60 million sorts of relationships. You might know Comcast from our cable product. This is probably our most well-known product, X1. It really changed the way people think about cable television. It's a great UI, it's easy to navigate, and most importantly, it has the voice remote that you can pick up and speak into the voice remote, and we'll hear what you said, translate it into what programs might be available to you, and tune to it so you can pick it up and say, show me the National League champion Philadelphia Phillies, and it'll tune you to the World Series. Yeah. Show me the only undefeated team in the NFL, it'll tune you to the Philadelphia Eagles. There are about 15 billion utterances that Comcast handles a year through the voice remote. And if you've used it, you'll probably never change channels any other way again. I was in the hotel last night and I had to actually press channel numbers and I just threw it away. Along with our cable products, we also have in-home Wi-Fi. Our home broadband system is anybody an in-home Wi-Fi geek? Because this is the best mesh network that I've ever played with. It's fantastic. Along with being a great Wi-Fi product, it also offers security. It offers the ability for you to have schedules where you might bring Wi-Fi up and down so that you can manage your household with it. There are about 100 billion devices connected to our Wi-Fi systems across all of our installations. We also have a product in the mobile space called Xfinity Mobile. We have about 5 million customers. It's not just a mobile phone product. We have many hotspots around the country where, as you go to them, it will automatically switch onto Wi-Fi, and you can use high-speed Wi-Fi on your phone without ever really needing to know that you needed to switch from mobile onto Wi-Fi. All of that's built on the thing that nobody really talks about, but is the fundamental piece of what Comcast is about, and that is a super high-speed, highly available network. All of this is a tremendous amount of innovation to make it all work seamlessly and reliably. And we know in Comcast that that innovation comes from our engineers. They are one of the most important commodities that we have, right? The differentiated engineering that we do is really the most important thing that happens inside Comcast engineering. So how do we help our engineers get to do more of that sort of differentiated engineering? That's what DevX is about. We know that when our engineers in Comcast are happy, when they don't have toil to deal with, when they don't have red tape to go through, their velocity increases. We know that when their velocity increases, innovation increases. There's a million studies on this. You can shake a tree and get all sorts of studies that show when velocity increases, innovation increases, and we know it's true. We see it in Comcast when we can remove this sort of red tape from teams. Our DevX team was put together to do exactly this sort of thing, right? To try to remove that impediment from our engineers so we can get to more innovation. Any engineers out here in the audience today? Anyone actually working in engineering today? If you are, you know this is an interesting time. DevOps is a great idea. We as engineers need to think a little bit more about the operations side of things. Operators need to think a little bit more about the engineering side of things. Those two things have come together. We are also, however, in the time of the great shift left, right? Everything that used to happen on the back end of an SDLC, we're trying to move forward to the front end of the SDLC. There is testing, performance, security concerns, privacy concerns, open source compliance, name it. Anything that happens in your SDLC, everybody wants the engineers to handle right up front. And that causes a pretty substantial cognitive burden on the engineers. Our effort in DevX is to remove that cognitive burden, and we can do it with software engineering practices. That's been done for years. What is really important for us, especially at the scale we're at Comcast, is giving our engineers an opportunity to have visibility into what their changes are actually going to do in production at a change level. That's one of the things we'll talk about. Today, we're putting some of our tools together using Elastic Observability to get that kind of visibility. We often have thought of operational visibility as purely an operations need, but as those concerns have shifted to the engineers to get started early, we recognize that it's a developer need as well. You can make a change in an environment as complicated as Comcast and not really know the consequences of that change onto all of the different neighbors that you have, because there's no way to simulate what happens in production until you get into production. Nobody has a pre-prod environment that has that much usage on it. You can't make one up. What we need to do in order to give the engineers the tools that they need to be successful when they're deploying their work into production is to give them an opportunity to see what's going to happen. It's an experiment, and then production is a control, right? You can see what your change is doing, and you can compare it to what's happening in production. So, making small, targeted deployments of our software into production in a highly visible way gives us an opportunity to compare those things. We're not testing in production. We're not throwing code into production that we've never really looked at. We're not sending this to people who have no idea they might be running code that's an experiment. We have targeted groups that we'll be pointing this to who understand that this is the situation that they'll be in, maybe have volunteered to be in this sort of pool, so we can gather this kind of data and let that iteration happen a little bit faster. Here's what the cycle would look like without that kind of integration. It always starts with the work that happens in development, right? And then we push it to some sort of QA environment where we run functional testing. We can't run all of that tests as automated tests. That's one deployment until we can get some feedback as to whether or not this works. Then we go to this sort of pre-prod environment that we hope might somehow look like production. We can't, because production's so big. We do get some feedback from that, though it can be useful, but the best value that we get is when we deploy our change into production and we can see how it actually works. Only then do we get the feedback that comes back to engineering that lets us take the next step and iterate towards the final thing that we want to deploy to production. What we're looking at doing is cutting that cycle down a little bit. The development still happens. It's the same development that happens today. And we push to more automated testing, a little bit deeper sorts of testing than we do today. Can't do all the kinds of testings that we do with functional testing, but we're sure that when we put this out there, we're not going to cause a disaster of any sort. And then we skip that whole pre-prod section, deploy this in a small targeted way, get our feedback from production, send that right back to the engineers so that they can iterate even more quickly and get what they need to make their changes work the way they want them to work in production. The key to this is high visibility into what's happening in your change. We heard a lot about what the observability stack is doing and how getting one single view into everything that's happening in your services is beneficial, and it's essential. You need to be able to see what's happening at the application layer all the way down through all of the hardware below you and systems below you so that you can see if you've done something incidentally wrong that impacts how your neighbors are behaving or how your change itself is behaving. One thing that's been highly beneficial to us in Comcast is consistency in schema. so that we know when we look at another service built by another part of the organization, what metrics they're publishing, what their logs look like. There are so many different teams inside Comcast that it would be impossible to figure out how your service is impacting another unless there was some consistency in how this works. We don't do a lot of standards at Comcast. We only do them when they're absolutely essential, but one of the standards that we have is our logging and metrics standard built on ECS, Comcast standards with extensions that allow us to gain that visibility and let teams work together so that we can see how these things work, scope our dashboards to the change so we can see what that impact is, and then compare it against how everything else is running in production. That's the sort of feedback that our engineers need, and that gives them an opportunity to move a little bit faster. And we end up with this. That visibility gives our engineers the feedback that they need. That feedback lets them iterate faster and can increase their velocity as a result. And we know that velocity turns into innovation. So those are some of the ways we're starting to put things together across all of our different tools inside DevX at Comcast using the Elastic Stack to get that kind of observability. I think we're going to chat about this a little bit now. Thank you. After you.
Thanks, Matt.
Of course.
We thought it makes sense to spend 10 minutes just chatting about what you're doing at Comcast. You've been a long-time user of Elastic. I just met some of the team over there. I think we met like 4 or 5 years ago, and we were talking about schema and consistent schema, and a lot of these discussions were the inspiration for things like ECS, for example. That is like the Elastic Common Schema. That, by the way, we donated to OpenTelemetry project and CNCF. So that's something that we're working on and trying to create like a consistent schema. I think that's good regardless. I think that's part of the fun things that we get a chance to make our products better thanks to talking to all of you here. So you talked about the changes that you're trying to do. The thing that I'm really interested at is, products help enable things that organizations want to do, but there's organizational change that is involved in trying to figure out how this happens. I don't know, observability and security are slowly melding together, but there's like a team in security and a team in observability, and how do they work together? Your changes that you're trying to bring more independent, self-sufficient units within the org that can operate at scale. How has that been going? Like, organizational change is not easy.
Organizational change is way harder than any technical change. It's been going really well. I think Comcast benefits from an environment of collaboration. It's really something that's built into the culture at Comcast, and it's been a big help to us, getting to this sort of spot. Because, as you point out, really we're talking about everyone having visibility into everything. If you have silos, if you have that sort of culture where people don't want to expose the information that they have, what their services are doing or whatnot, it really causes a big impediment. So I think change starts with talking about where you're trying to get, what you're trying to do, why are we trying to make our developers faster, and then getting that sort of collaborative environment where people can share ideas. And we talk about it a lot. We build our office floor plans that way to try to stimulate collaboration, but it really comes down to people trusting each other.
I completely agree. Like in Elastic as well, for example, we start projects that don't necessarily map to your organizational lines, right? It's like ESQL ended up picking up a few team members from the query language and other places, and I find that it's all about the people. Like if people go and sometimes fight through the hurdles that any organizational structure puts into them, because there's no perfect ones, like that's when it matters. And then I guess the role of the organization is to try to keep up with great people and support them. So that was part of it. Can you talk a bit about what in Elastic help enable that? As we spoke a bit about observability, but I'd love to know a bit more about the things that you use in Elastic and the products, and how does that enable this change?
It all comes down to that visibility, right? You have to think of Comcast as many, many different teams all functioning on their own set of goals, almost like a free market. What we're trying to do is bring cohesion to the work that all of those different teams are doing. And there are impediments to that sort of cohesion because everybody wants to go on their own kind of vector. The key, though, is gaining a real understanding of what other teams are trying to do so you can work together, right? So that you can build that kind of cohesion. So really the fundamental important piece for us has been Comcast Common Schema built on top of ECS so that people really can understand what all of the other tools are doing. That's really been the fundamental piece. Now, getting everything into one place so that we can see it in dashboards, getting visibility into what's actually happening by looking at distributed trace. It surprises people sometimes to see all of the services that are involved in some sort of service chain. I mean, I said sometimes, it surprises people almost all the time to see how all of that goes together. Gaining that visibility, sharing it with people has really been the key for us to make the sort of progress that we do. People do want to work together. They often don't know that they have to. And this visibility gives them the opportunity to know that.
That makes a lot of sense, and to a degree, it goes back to what I'm very passionate about, which is like take data and put it at the hands of users, and then magic happens, and that's a lot of like a very fundamental first principle way. It's what we're trying to do with Elastic. So you heard about some of the things that we've been working on, or some of the things that we're going to work on. Any favorite?
AI Ops.
AI Ops?
AI Ops is huge. I mean, when you look at again, we go back to the complexity of the environment, right? Understandable, right? You can't comprehend the full complexity. I don't think I'm going out on a limb to say nobody really understands how everything works at Comcast. You can't. No human being can. So getting to AI Ops where machine learning, where the machine is helping us understand the signals that might imply what's going to be happening in our operations is going to be a big, big help for us, right? It's going to free people up to do, to get away from the mundane tasks that we do and get more towards those sorts of novel tasks, right? Let the machines do the hard work to figure out what's going on.
I completely agree. I think there's a lot of, one of the ways that I think AI, and that's buzzwordy words, have been implemented in the field is GitHub Copilot. And like sometimes naming matters. It's like the difference between we'll auto-code everything for you compared to we're your Copilot. Like we're sitting on your shoulder trying to help you move fast and telling you where's the navigation and how to move. And I think a big part of AIOps to me is exactly that. Like we sit there in front of data and do so much work that we can have a co-pilot next to us that can help us go and focus on exactly the things that we need to do.
The best operations people have a sort of understanding of the zeitgeist of how all of the system is put together. It's hard to train that, right? When AIOps can point it out for you, you can get there faster.
Totally. Like when you can analyze an exception to what's going on in the system, you might not be able to immediately understand what it is, but it's great that those are the ones that you need to deal with as an engineer versus everything, and then going through a lot of data. Well, thank you very much. When I lived in the US, I was a very happy Comcast user. Things just worked, which is probably the best thing that you would have in a system. But yeah, thank you.